We have 3 touching circles, one with a radius of 10 meters, the blue one's radius is 5, and one that we're trying to figure out. If you want to try this problem on your own, pause the video now, because we're about to begin. The first thing we're going to do is draw a line vertically down from the midpoint of the pink circle. We know that it's 10 meters long because we've been given its radius. Next, we can draw a line from the midpoint of our smallest circle to intersect the line we've just drawn. And to complete the triangle, we're going to draw a third line from the midpoint of the smallest circle to the midpoint of the largest one. We have now created a right-angled triangle, meaning we can now use trigonometry to start working out the lengths. We know that the distance from the ground to our horizontal line is equal to r, so the length of the first side of our triangle is equal to 10 minus r. And similarly, we know that the radius of our large circle is equal to 10, and the radius of the small circle is r, so the length of our hypotenuse is equal to 10 plus r. Now we know 2 of the lengths of the sides. We can use Pythagoras to work out the third length in terms of r, where a squared equals 10 minus r squared, b squared is the length we're trying to work out, and c squared equals 10 plus r squared. Working it through, we find that b squared equals 40r, so b is equal to the square root of 40r, and we can add it to our diagram. Next, we want to figure out the distance between the midpoint of our small circle and the midpoint of the blue circle, so that when we combine it with the distance we just worked out, we will know the distance between the center points of our 2 larger circles. To do this, we're going to draw more lines and connect them into a right-angled triangle. We know that the radius of our blue circle is 5, and the radius of our pink circle is r, so the length of our hypotenuse is equal to 5 plus r. We know that the length below our triangle is equal to the radius of our pink circle, so the side of our triangle is equal to the radius of our blue circle minus r, or 5 minus r. And we can now use Pythagoras to work out the final length, where a squared equals 5 minus r squared, b is the length we're trying to work out, and c equals 5 plus r squared. So working it through again, we find that b squared equals 20r, and b is the square root of 20r. And now we can use the combined lengths we've just worked out to solve for r. And we're going to do it by, you guessed it, drawing another triangle, right angle included. And we know that the hypotenuse length is the radius of the pink circle plus the radius of the blue circle, which equals 15. And we also know that the a side length is equal to 5. From our previous 2 equations, we can say that the b side length is equal to the square root of 20r plus the square root of 40r. So our final equation is 5 squared plus the square root of 20r plus the square root of 40r all squared equals 15. Simplifying this equation, we find that the radius of our small circle is 1.72 meters.